Hello, hello everyone. We are now in our We Do problem together, where I am going to need your help in order to solve this sex-linked problem. Now again, we're working with sex-linked. We're going to do this together. So hemophilia, and if you remember hemophilia, this is a disease where people aren't able to clot their blood properly. So if you get a small cut, it could actually cause you to bleed out and die. Generally, it's not just a simple small cut, but things that aren't as major. Okay, so hemophilia in humans is due to an X chromosome mutation. What will be the results of mating a carrier female and a hemophiliac male? So we need to create a key for ourselves, and there's some things I want to keep in mind. So we got to figure out, is hemophilia dominant or recessive? Is it dominant or recessive? And the fact that this says that there is a carrier involved tells me that this has to be a recessive disease. And the reason for that is because if you have a big H, there's no way you could be a carrier. You're always going to show the trait if it's dominant. But if you have a recessive allele, then you could be a carrier. Okay, so remember with females are XX, males are XY. Alright, so let's create a key here. What would the genotype be for a healthy female? What is her genotype going to be? Alright, it's X big H, X big H. What about if she is a carrier female? She carries the disease in her genetics, but she doesn't show it. Okay, it's X big H, X little h. That's the hemophilia disease right there. What would a sick female be who has hemophilia? Okay, this is X little h, X little h. She has both recessive traits, and so she would be sick. Okay, what about a healthy male? What would his genotype be? X big H Y. And a sick male, X little h y. That's that hemophilia. Okay, so in this problem, what's the result of mating a carrier female and a hemophilia male? So what is their genotypes going to be? Carrier male and hemophiliac male. Carrier female, I mean. Okay? So we should have gotten X big H, X little h, and X little h y as the dad. We're going to take this and bring it to the Punnett square. Okay, what would go in this first box? X big H, X little h. What about this next one? X big H Y. Good. This third box. X little h, X little h. And the last box. X little h y. Okay, time for the analysis. And I'm going to need your help here, guys. So we need to create a genotype ratio. Rather, what I want us to do is create a percentage. Let's create a percentage for all the different genotypes and phenotypes. So let's start with genotypes. For the girls, or females, what are the different genotype percentages? So before we answer this, we got to figure out which ones are boys and which ones are girls. I'm going to divide this in half. You see that these two are girls, these two are boys. Alright, so what would the genotype percentages be for the females? Okay, 50% are X big H, X little h, and 50% are X little h, X little h. And let's do the boys. What would the males be? Their genotype percentage. Okay, 50% X big H Y, 50% X little h Y. See how we got this? So this came from here, and this came from here. The reason why it was 50% is because we're treating the girls and the boys separately instead of looking at it as 4 squares. We're only looking at 2 at a time. That's why it's 50%. Alright, so let's do the phenotype ratios or percentages. For girls, how many of the girls, or what percentage of the girls are going to be hemophiliac? There are 2, or rather 50% will be hemophiliac, and then 50% will be carriers. 50% are carriers, 50% have hemophilia. What about the boys? Okay, 50% are healthy, and that's this one right here. 50% of their 50% of their boys, and 50% have hemophilia. And this again was for boys, and this was for the girls. Okay, so let's do the full the follow-up question. How many offspring will have hemophilia in general? So notice, this is not looking at boys and girls separately. It's actually looking at everyone together. So now we're going to look at all 4 squares. What do y'all think the answer would be? Okay, so I can tell that this child has hemophilia and this one does as well. So 50%, 2 out of the 4 boxes, 50% of their offspring will have hemophilia. 50%. Or 2 out of 4 of the kids will have offspring, or you could simplify this as half of them will have it. And that would be your final answer. Good job, guys. Together we have answered this sex-linked problem.